Yes, students, we are discussing over here the chapter named as aldehyde, ketones and acids. Now in this particular module, if you remember, we are right now moving ahead in the interior part of the chapter as chemical properties. Now in a chemical property, basically the first point to be remembered is what is the reactivity of aldehydes and ketones. Let's move ahead. Now student, one point is very important over here, that aldehyde and ketones, they normally likes to undergo nucleophilic addition reaction. Over here on the screen I have got a carbonyl group, and do you know that student, oxygen is more electronegative than carbon. So what will happen because of that? The bond will become polar, yes, and you will have got delta plus on carbon and delta minus on oxygen. Now I have got, suppose, a nucleophile, yes, which is an electron rich. So obviously it is going to attack nothing but an electron deficient center, and yes, in our carbonyl group it's nothing but the carbonyl carbon only. So nucleophile will like to always approach the carbonyl carbon, and hence always remember one thing, nucleophile always goes to carbonyl carbon. Now let's discuss the reactivity of aldehyde and ketones. Now we have one thing, student, comes immediately in our mind, sir, among aldehydes and ketones, which one is more reactive? Yes or no? Yes. So how to answer that? So for this we have got two important factors to decide this, and the first factor is steric hindrance, and the second factor is nothing but the inductive effect. That's the positive inductive effect of the alkyl group. Let's start with the first one, student. Here I have got a carbonyl group. Yes, I have taken three cases of a carbonyl group. In a first case, if you see, I had got, suppose, both the H's, then it becomes formaldehyde, student. Suppose if there is one alkyl group and one hydrogen, it will become an aldehyde. Similarly, in the third case, if I have got, suppose, two alkyl groups, maybe same or maybe different, then it will be called as ketones. Yes, students. Now what? Now student, we know one important point, that aldehydes and ketones like to undergo nucleophilic addition reaction. Now if you see those three cases which I have taken, can you see one thing? I have shown a size of an atom. In the second example also, if you see in the aldehyde, I have shown a size of an atom. In the third case, if you see again, and a ketone, a size of an atom is shown. Now student, from this we can make one conclusion very clearly, that the bulkiness is increasing from formaldehyde to aldehyde and from aldehyde to ketone. And remember student, our reaction is an nucleophilic addition. Addition means something is going to be added, and when the things are to be added, always the space problem comes. And yes, in our case also, if you see what is given, the first one is the least bulkier, the second one is the more bulkier, and in the third case, if you see in ketone, it is most bulkier. So nucleophile will find it very difficult to go near to carbonyl group in the bulkier molecules, and hence reactivity wise, formaldehyde will be the most reactive and the ketone will be the least reactive, students, and hence the order becomes is formaldehyde is more reactive than aldehyde is more reactive than ketones. Yes or not, student? Easy. Let's go to the second point, and the second point is positive inductive effect of the alkyl group. So here again I have got a carbonyl group where oxygen is more electronegative. Because of that, the bond is going to become polar, carbon carrying a delta positive and oxygen carrying delta negative. Now similarly I can take other two cases also of a carbonyl group where phenomena remain same. In the first example, if I put two H's, it's formaldehyde. In the second example, if I put one alkyl, one H, it becomes an aldehyde. In a second or third case, if you see, if I put two alkyl groups, maybe same or different, it will be known as ketones. Now student, if you remember, we have discussed one point, that this is, or aldehyde and ketone, if you see, what is the difference you can see in all three compounds? Yes, student. Yes, it's an alkyl group. And if you see, what is so special about alkyl group? Yes, alkyl group is an electron donating group. So whenever it's an electron donating group, what happens? The electron has been given to a carbonyl carbon, because of which the intensity of a delta positive charge gets minimized or it becomes less. Similarly, if you see in the ketone, two alkyl groups. And in both the alkyl groups, they are electron donating. So what will happen to a delta positive charge? Yes, it will decrease much even than aldehydes. So now, if you remember, student, it's which reaction? It's a nucleophilic addition. So nucleophile always goes and attack where? To a carbonyl carbon. And in all those three cases, if you see a carbonyl carbon situation, how it is? Yes, the delta positive is maximum in formaldehyde. In aldehyde it is less, and I think so in ketone it is least. So will you tell me now nucleophile can attack easily? So yes, one point is very clear, that positive inductive effect will always decreases or reduces the electrophilicity of the carbon atom. So formaldehyde will be the most reactive and your ketone will be the less reactive. Hence the reactivity order would be formaldehyde more reactive than aldehyde, aldehyde more reactive than ketone. Is it not so, student, easy? Yes, we end with this module over here. Thank you.